And good morning and afternoon. Welcome to episode 37 of Codebase Alpha, and we're continuing to look at our software synthesizer, so our digital synthesizer we're building using .NET Core 3 and WPF, and using the N-Audio library. So yesterday we've kind of finished off adding a few new features. We added a low frequency oscillator. No, we didn't add that. We had a low pass filter, sorry, and we added a tremolo effect. Today I want to have a look at low frequency oscillators if we can get that far, but I also want to do a bit of work on the GUI. So you can just watch me struggle through some WPF XAML programming. So let's get straight into the code and see where we are. Okay, so here we are in the main view model, and we want to pop across to the actual XAML file. Okay, here we are. So this is our current layout. We have our envelope settings here, which we created yesterday. I've tidied up the layout from yesterday. We've got some titles across the top, and we've got some labels on the bottom here. These probably need a bit of fiddling with because we just need to make sure that all the various values fit in there, which they may not at the moment. So let's have a quick look at that and sort that out if we can. So let's start up the synthesizer. Here we are. So this is our synth, and if we look at these controls, so this control goes from 0 to 200 milliseconds, and we can see the milliseconds is being cut off there. The same here. This is 100% and 0, so that's absolutely fine. And the release will also go up to 200 milliseconds, and you can see it's also being chopped off a bit there. So we're going to need to try and sort that out. 200 milliseconds. That's not quite right, I don't think either. So we're going to need to have a play there. So let's start off with that. So okay. So these labels need to be a bit bigger. Let's have a look where those labels are. Where are they? Here they are. So they're currently 50 in width. No, that's these are the labels here. So they're 40. Let's make them 50 in width and see what happens there. 50 and 50, and let's move them all out. So we're going to need to adjust the margins. So let's bring the margins back to 10 and let's reposition those labels. Luckily, it's quite useful. We can. Oops, that's the wrong one. That was 40, 50. It's this one here. We can see that the labels are lining up nicely with the bottoms of those sliders. That needs to cross a little bit further. 8. That's probably about it. Okay, let's run that and see what happens. Okay, so 0, and we're going up to 200. So that's not really 200 milliseconds, is it? Those are the wrong figures. So let's make that more correct. Okay, let's stop that. Okay, we need to go into our main view model here and fix up those labels because that's not in milliseconds. So we need to be able to have 100 rather than by 1,000. So we need to put volume by 1,000 rather than 100. And the volume was correct, not that one. So the decay and the release should be multiplied by 1,000, not 100. That's a copy-paste error. That one there by 1,000. This one by 100 is correct. That's a percentage. Let's see what effect that has on our labels now. Okay, so 300 milliseconds. That's more like it, and we're going up to 2,000 milliseconds. That's correct. That one just needs a bit more width, as does that one there. this one, I think they all need a slight tweak in the width again. Let's do that. XAML file. Okay, here we are. So we're going to make these, say 55. I think that makes a difference, and we need to then bring that back by 5. So that's back to 3. That one to 5. That one to 5. And that one to 5. So I think that should bring them all into line again. Let's try that again. This is me fiddling around with GUIs. I'm not an expert at this kind of thing. So there we are. That looks okay now. That's the milliseconds. All showing nicely, so that's good. So we can move on to the next bit of GUI work I'd like to do. And we, as I said yesterday, we introduced a couple of features. We introduced signal generators, which we're going to, instead of wavetables, for doing our kind of noise making. So let's have a play with that. So I think we're going to need some more columns. So I'm going to introduce a new column in here, like that. So we need to also expand our frequency analyzer to go across that new column. So let's go down to the bottom here, and the column span here is going to be 5 now. So it spans 5 columns. There we go, that's looking okay. Let's save that, and then this here is stretching all the way across, and I don't think that's right. So let's so that's our volume, that's our octave control, which is here. It's a column span of 3. I think that needs to just be the column span of 2. But that now fits nicely in there. We've got some extra columns to play with, which is what we want. So in this column here, we're going to put our wave selector. Okay. So let's have a look. This is in so we want our octave selector, which is here. This is in row 3, and we want to be in column 3, don't we? Okay, so let's make some space for a new stack panel. That stack panel is going to be oriented horizontally. We don't need a name for it, so let's just lose that. That's our stack panel started. So so we're going to need a label in there first. We once again don't need a name. So the content of the label is going to be low pass filter. No, it's not going to be low pass filter. This is a wave selector we're doing, isn't it? So waveform. So that should be okay for that. Let's make that bold. So font weight can be bold. And so the vertical alignment, I think we had it at top. So we want to be rather like our octave that was top, and the horizontal alignment was right. So we'll do the same thing. Yes. Yeah. Vertical alignment top, horizontal alignment top. So that should give us. Okay, yeah, we need to put our stat panel in the right place, don't we? So the stat panel is going to be in. So this one was in grid row 3, column 2. So let's copy that. Stat panel, grid row 3, column 2, column 3. And there's our waveform label appearing. It needs to be in the center by the look of it. First alignment should be center. Let's try that. Okay, looks better in relationship to the octave selector. Okay, so what next? Let's have our radio button. So let's just pinch some code for a radio button here. Just copy that down. Okay, so this radio button's name is going to be sine. So we're going to have a sine wave selector. The text will be sine. We're going to the group name is going to be waveform. And we're going to create a new method on our main class, which is going to be called set waveform. Okay, so that's sine. So we need a few more of these. Let's copy this. Bang, bang, and bang. So we've got our sine. Then we're going to have sawtooth. I should say sawtooth. And this is not going to be checked. We need to get rid of those is checked. And there. That's that one. Then we're going to have square. Square, and finally we're going to have triangle. Oh, we need here we got sawtooth. Triangle. So there we go. That's our selection of wave forms. Let's just tidy this up a bit. Well, I think we should be able to do a format document there. That's better. Okay, that's our new stat panel, and that's how we're going to be able to select our waveforms. Currently 4 waveforms. We also have kind of white and pink noise we could select. Doesn't make an awful lot of sense to choose them here though. Rambling Geek, Kogi Beard, welcome to the stream. Good to see you. Thank you for joining. It's yeah, it's been a bit of a hectic day today, so I'm glad I actually managed to arrive at streaming just about at the right time. Okay, so let's wire this up then. We're going to need to have over in our main window example.cs, we're going to need a method which is basically going to be very similar to set octave. So let's copy that, pop that down here. We call this set waveform. And here it's going to be sine sawtooth, I think it would be, square and triangle. So how are you guys? You okay? You still at work, Rambling Geek? Go to bed? Okay, so triangle. Okay, so we've got those. So we need a property over on the on our view model for the waveform. Let's create a property which is going to be a automatic property. Well, it's going to be a public signal generator type waveform. How do we get set on that? Okay, so now we should be able to set that from our main window. So this is going to be waveform, and this is going to be signal generator type. Signal generator type dot sign. And we need to bring that in. Looks like I've got two waveforms. Waveform. Got a waveform equals waveform here, which is okay. We'll change the name wave to wave type. Wave type. There we go. Over to our XAML here. This is going to be wave type. Just copy these. Technically, you're finished work, are you, Cody Bear? But you're dealing with idiotic stuff, and that kind of tends to be kind of par for the course as developers, doesn't it? Dealing with idiotic stuff. I know I have to do that all the time. So a square wave there, and a triangle wave. We may expand this to use the different types of the pink noise and the white noise as well. But this should be enough for now. So that should set our wave type. And then over in our main model here, we've got our wave type set now. And when we go over here to the key down, when we instigate the creation of our sound, we can then pass in wave type into there. Okay, so we should now have UI control over the type of wave we create. So let's fire this up and give it a go. Again, we'll switch on. We're currently doing a sine wave. That's certainly not a sine wave, is it? What's going wrong there then? Okay, interesting. Okay. So let's pop a breakpoint in at this point and see what we're setting it to. Let's set this to... Oh, maybe it hasn't been initialized. Maybe that's the problem. And that is a sawtooth. So let's remove the breakpoint and continue. Yeah, I think it's just an initialization problem. It hasn't been set to initial value. So let's set it to initial value here. This is going to equal a signal generator. Generate type of sine, because that's our default. Is that squiggle going to go away? Yeah. There we go. Cuddybeard, the 20-year-old WinForms app that's finally been stopped working. .NET Core version is ready, but not but waiting for sign-off from a business analyst. And they're trying to get you to fix the 20-year-old version that we don't have the source code for, which is the very reason you did the conversion. Absolutely. So, wow. Yes, how are you going to fix it if you haven't got the source code? Magic, I guess. Got a bit of an artifact in there. Clicking, I'm not sure what that is. Let's I never used to have that clicking. So that's interesting. Let's have a square wave. Triangle wave. Sawtooth. I'm not sure what that clicking is, so I'm going to have to investigate that. We didn't have that clicking before. What could that clicking be caused by? Let's just temporarily comment out that bit of code I just put in. Let's put signal generator type dot sign in there and see what's happening. Does that still have the clicks? Does have clicks. So that's a bit interesting. So it's nothing we've done that's caused those clicks. So I'm going to take that off stream, I think, to look at why it's clicking. So Cody Bird, the issue is that the user is at a site with a terrible network connection and the app has no error handling. So when they run a massive SQL query, it just crashes. He worked around it by putting the old app into a VM next to the DB server and getting them to remote into the VM. Betty Slace, welcome to the stream. Good to see you. Thank you for joining. Okay, well, we'll have to figure out why it's clicking. Yeah, interesting. I'm not sure why that would be. What we'll do is we'll implement the GUI controls for the low pass filter, and then I want to look at low frequency oscillators really as the other part of the stream today. I'm not sure how long I'm going to go for, but let's just see what we can do. So here's our low frequency oscillator, our low pass filter. We've got some default values, cutoff values in here. So we want to switch this on and off, and we want to vary the cutoff frequency and the kind of the Q, the aggressiveness of the cutoff curve. So Cody Beard, on a more positive note, the Synth app looks like it's coming along nicely. You've certainly done a better job of the UI than I will. Yes, well, I have to work on the UI. It's not a Fuel Snable did the nice graphics of the spectrum analyzer and the waveform depictions, so I didn't do those. So, but the rest of the GUI I am working on. I'm trying to get to know what you can do in WPF. I'm just scratching the surface. All I'm doing is kind of hacking XAML at the moment, and there's an awful lot more that you can do, I think. Okay. So that was our waveform selector, and now right next to the envelope parameters, which we can set with those sliders there, I want to have the low pass filter control. So let's have a look at that. So this is going to be after this block of controls here, which means it's going to sit in here somewhere. Okay, so we're on to stat panel again. I seem to think the stat panels are at least the initial way to go with this. And our stat panel is going to be in grid column. So that's column 1 in 3, I think. No, it's going to be in column 2. Column 2. Let's give it a go at column 2, and it's going to be in grid row. Grid row number 4. Okay, that looks okay. So this is going to be the labels across the top. So the same way as we got the labels here, we need some labels across the top. Let's create a label. We don't need a name for our label. So let's remove the name. Okay, Cody Beard, see you in a bit. So the contact, what's the contact going to be? It's going to be a low pass filter. Oops, what have I done? I deleted it. So low pass filter. And we'll make that bold, so font weight is going to be bold. Okay, that should be okay. We probably need to put some margins on that. So let's set up an initial margin of 15,000, and we'll fiddle with that as we come along. So then we need some more labels. So we want two more labels. We want a label which says cutoff. So this is the cutoff frequency, and this is not going to be bold, so we can get rid of that and that. And the next one's going to be our Q, which is our kind of viciousness of attack, our aggressiveness of attack on the cutoff. Okay, so that's those components. So we want another stat panel that's going to go underneath that. Once again, it's going to be a horizontally arranged stat panel, and it's going to be in grid column 2, grid row 5, so it should go down here. We should be down here. Looks like we are. So we want to switch this on and off. Now, I did have a quick look about what controls we've got were suitable for switching things on and off. And what I'd like is a nice toggle button, but there isn't a toggle button out of the box, so we'll have to use a checkbox. And this checkbox is going to say enable. Okay. So on the checkbox we have a number of controls. The checkbox is going to need a name. The name's going to be low pass filter. And we're going to have a checked method, and we're going to create an event handler for that for us, and an unchecked method, unchecked event. We'll get to create the event handler for that, and we're going to have a vertical alignment. It's going to be at the top. Okay, so that's our checkbox, which is going to go there. So we're going to need to fiddle with the positions of all these things, but let's get the basic components in. And then we need a couple of sliders. So let's go and pinch the sliders from here. These two sliders will do. Okay, we'll drop those into there. And they're almost in the right position. They need to be moved across a bit. So let's say, I don't know, by eye 70, nearly 74, 75, 76, 77, 78. Let's try 90. Oops. It's a bit far, isn't it? So 88. Nope. 85. Let's leave it at 85, and we'll worry about it later. And our Q needs to come across a bit towards the left. So let's drop the margin of that to 20 and see where that brings us. That's pretty much correct. Okay. So we need to change the details here. So we're not going to bind to the attack, we're going to bind to the cutoff. And here we go, this is going to be bound to the Q value. I believe that we're going to have Q going from 0 to 1, but we'll try increasing it above 1 and see what happens at some point. Our cutoff will take from 1000 Hertz, remember this is low pass, to let's say 8000 Hertz. And then we'll be able to kind of have a fiddle and play with that and see what happens. I'm not sure exactly what effect it's going to have, but we now we've got when we get the GUI controls all wired up, we can actually experiment and try them out, which is something which we can't do very easily in the if we kind of fiddling with the program parameters and having to run the program each time. It would be nice actually to have little tick marks against these these sliders. So let's try creating some tick. There's something called tick placement, and if we select top left, it should appear on the left. And we need a tick frequency, and this is like a 7,000 Hertz range. So let's have them every 200. They're quite close together on that, but that'll be okay. And we'll copy this over here as well. We'll have the same kind of idea here. But we don't need it every 200, we just need every 0.1. So we've got some tick marks there, and I think we need to kind of shift things around a bit. The cutoff frequency needs to move now a bit to the left. So rather than 85, let's try 80. A bit more. 78. That looks okay, and this one can be, I don't know, 15. A bit less. 12. That looks okay. There's our cue. The tick marks are very, very faint. In fact, what we can probably do is give ourselves a different background colour as well to the whole thing, because it's very white, isn't it? I don't know. I tend to use dark theme for everything, so let's make this a light grey colour. Light grey. So the tick marks maybe stand out a little bit better. We want some tick marks on these as well at some point, but we won't worry about that too much. And now we need some value labels to appear in this row. So you can see here there's value labels here, kind of sit underneath these numbers. So we need the same kind of idea here. So that's the waveform, that's the envelope, and here's the another stat panel we want now. Oops, stat panel. So this time we are going to be in the row below. So this is going to be grid row 6, and we want a label. The content is going to be that's going to be a binding. So that's curly braces. That's the name. You don't need a name. The content is going to be bound. So we put curly braces, put the word binding, and then we're going to give it a name. So this is going to be cutoff label. Cutoff label, and we need some kind of width on that. So it's going to give it a height of I don't know, 20. Just guess at the moment, and a width of 40. And we'll see what the values, how the values fit in. Width of 40 is going to be too narrow to get 1,000 in. So I think it was 50, wasn't it? We ended up with on the other one for thousands. So it's going to be kind of 8,000 Hertz is the maximum, and 1,000 Hertz the minimum at the moment. So that should be okay. And then we want a margin around that so we can adjust it. So margin. And for the male, we'll just put in 120 to move it across. 0, 0, 0. So it needs to come across a tad more. 125. Okay, that should be okay. And we want another label now. So this is going to have, let's put 0 in there for now. Okay, they're kind of running into each other, aren't they, these two labels? Let's see what it looks like. This is going to be our Q label. And this probably doesn't need to be 50, does it? So it can be probably a bit narrower than that, 40. Let's give that a go, see what that looks like. So Let's go, and first thing we need to do is go over to our XAML.cs, and we should have had some events built into here, which we have. Okay, so on here we can say when it's checked, if the view model is not null, well, then we can go into the view model. We can say view model dot enable low pass filter equals true. We haven't got that variable yet, so that's why it's underlined. And here we'll have to false. Let's go and create. Let's have a lowercase in there. Low pass filter. Okay, over to our view model, and we want another property, which is going to be a public bool enable low pass filter get set. So we should be happy now across in our XAML.cs. That is. Okay, so that with the switching on and off of it. So now it's generating the generated view model. So we've got a T4 template which FuelSnable kindly kind of created for us. So we can kind of do this generation of the view model bindings automatically. So what we've got is two. We've got an int value, a float value, and two strings. So let's just copy these two here. So we've got a property which is going to be an int. That's cut off. I believe that's what we called it. Let's go and make sure that's what I called it over in the XAML window. It's cut off, yeah. And we've got cut off label as a string. And then we had Q, which was a float, and Q label. Let's just tidy the layout up a bit. Okay, we'll save that. If we run this T4 template now, it's going to generate our view model. You'll see we get a tick now up here in the generated view model. So now we have those bindings all set up for us, and we can go back to our main view model, which is a partial class. So the generated view model is the other part of the partial class, and we can come down into here. Okay, so what's the best thing we can do to begin with? So we've got some changed properties. So we have a couple of these, I think we'll have. So we'll have a changed cutoff, and that'll be a couple of ints, the previous and the current. That should go away, and so that the cutoff label should just be equal to the value of cutoff. And we'll just put hertz there. And then the other one was a change in Q, which is a float. And there'll be a Q label, gets updated. And this is going to simply be just the value, and I don't know what the units really are, so we won't put any units. I'll try and figure out what the units are. So this is going to be Q. Okay, so that's those bits set up. So let's make sure that wiring up has actually worked, because it's always kind of interesting to see the Q template working. So we haven't got any initial values in here. So it looks like those changes works on that one. We're not seeing any change on that one there. And so it's not big enough. And we want to give initial value of 0.7, I think. So let's sort that out. So on construction, our cutoff is going to equal 4000 Hertz, and our Q is going to equal 0.7, which are the kind of default values that we set up in our low pass filter, and they seem to work quite nicely. We need to go back over to our main XAML window. So this, are they overlapping? Is that why we're not seeing anything? I think they're overlapping, aren't they? So we're going to move this one across a bit. So let's move this to 115 and see where that ends up. And this one, a margin of 5, a bit more, 10. So they're no longer overlapping. So that maybe will help that. Let's run it up and have a look. So we need to make it higher, but this one still isn't visible. Even though we look up, we are at 4,000, but by the look of it there. Okay. So in terms of the height, the label heights need to be greater. So it makes that 30 and 30. And it could be this isn't wide enough, I suppose. So let's make the width of this 60. Let's see if that makes a difference. So that's looking okay now. We need to fiddle with, because it's got too many digits. This one here though, we're not getting anything linked up. Okay, let's have a look at that. So we've got it's cut off label, and rather than cut off label, so we've got to leave it as that because we've generated our binding on that, did we? No, I don't think we did. I think we generated it on a cut off label on our T4. We did. So let's just sort out the label for this. So we want to take the integer value of Q multiplied by 100 and multiply the whole shooting match by 100. 0 f 0.0 f, and see if that makes that a bit cleaner. A bit kind of GUI fiddling going on at the moment. So that's 4,000 Hertz and that's 0.7. So that's a lot better, isn't it? Okay. So let's give it a go. Let's see it working. So with a sine wave is really pure. We're not going to get many high frequency things to be cut off. But if we go to a saw wave, you'll see if I play that note, which is the note A again, we got a lot of high frequency artifacts. Let's enable our low pass filter, which we haven't done yet, so it's no point in doing that. So let's stop. Let's go over to do that enabling of the low pass filter. And also, do you notice how buzzy that sawtooth is? It's got a lot of high frequencies in there. So if we can make that a bit kind of more pleasant, a bit smoother, it'll improve the kind of listening experience. So there's our low pass filter. We want our view model and we want the key down. So here's where we got the choice of adding the low pass filter or not. So what we'll simply say is that if enable low pass filter, then we'll simply do we'll do that. Else we'll do this. This is very simple. Can we convert it into a tertiary expression? Let's do a tertiary expression and just make it a bit more difficult to read. There we go. Looks a bit nicer. Okay, so that should either put a low pass filter in or not, as we can control it. So let's give that a go. Okay. So let's have a sawtooth wave. Let's play. There's A. Switch on first. Let's put a low pass filter in. You can immediately see that it's not quite as harsh. So let's lower the cutoff to round about there. Then we can try fiddling with these. Not exactly obvious what's going on. It is making it, the cutoff frequency is definitely affecting that sound. We probably need to have a bit more kind of a thought about the range of these low pass filters. I'm not sure about this range, whether this range can exceed 1 or not. We'll leave it at 0.7. Switch that off, and if you play again, you'll notice the difference. But very buzzy, a bit mellower. So I think that's quite a nice feature. We can try it with square waves. It's interesting to see the harmonics in there. The triangle wave without the low pass filter. So it's attenuating the peaks a bit at the high frequencies. So we need to kind of investigate a bit more about the kind of filter theory behind that and see what we can set these values to. Okay, so that's pretty much what I wanted to achieve from a GUI point of view. We've got, if we go over to our issue list over on GitHub, so waveform selector, we've done a waveform selector. So we did sine wave, sawtooth, triangle and square. We've still got to look at pink noise and white noise, so we'll leave that issue open for the moment and we'll have a look at setting those up. And the other one was the low pass filter, where we said here yesterday that we needed to add the controls, so we can close that issue. Controls added to the GUI. Comment on that. Okay. So what else have we got? We can go in on. We did the tremolo effect, and probably need to wire that in. I need to have a bit more of a think about that tremolo effect, mainly because of the position where we are actually inserting that effect. If we actually go over here and have a look at where that effect gets implemented, it is here in the constructor. And so we don't really get the opportunity to change it once we've constructed it. So I need to think about how we're going to do that. And I think it's going to be a matter of having, rather than having the tremolo on or off, we're just going to have the tremolo have no effect. So we're going to put, at the moment, the tremolo as a fixed effect. So currently it's as a low frequency of 5 Hertz and an amplitude of 0.2 to give a nice variation in the volume as that tremolo comes in. We want to be able to control those, but when this is off, basically if we pump in a frequency of 0 or an amplitude of 0, then it's going to have absolutely no effect. So hopefully we can maybe put a bit of code in here to say just pass the buffer straight out again if these values are 0. In fact, maybe we could do that now. So so what we could do is simply say if low frequency oscillator amplitude, so gain, if gain equals 0.0, we've not got gain available to us. That's on the signal generator. That's Lfo gain. If it's greater than 0.0, I'm sure it does contain no definition for gain. Interesting. Why can't I get at gain? Doesn't seem to want to give me access to gain. It looks like it's a get set. Oh, it's because it's an I sample provider. So if we make that a signal generator, we should have access to it then. Yeah. So if it's greater than 0, then we can apply that. Else, we're going to simply pass the buffer straight out. We're not going to process the buffer at all. In fact, we just don't do anything. We don't do anything. Just return the raw buffer that we've got input. That should be okay. And that should be an I, shouldn't it? Not 1. Okay. Well, let's have a listen to that then. So where's more tremolo? So we're feeding a tremolo in. Did we leave it so it was processing the tremolo? Yep, let's start it up. I'll have a sine. We've definitely got a wobble there, haven't we? So let's switch that off and then just pass 0 into the as the gain on that. So tremolo is going to be that, and we're going to say the tremolo, the low frequency. No, that's not right. We can pass it in on the command line, the parameter line. Volume control, and then we've got a frequency which we'll leave at 5, and then we've got a gain of 0.0. We'll pass those in, and we should not get a tremolo effect anymore. Oops. .0f. There we go. Switch on. The sine wave shows you at best. We'll play the note A, and there's no variation. You can see here on the picture we've got a very steady sound there. reason why we've got this kind of curve is we've got an envelope on that. And that's the fundamental. Try shifting around. Low pass filter. It should have no effect. There's virtually no high frequencies. That's a nice bit of chordage. Let's look at that chord again. So you get quite a nice kind of output there on the screen, which I quite enjoy seeing. Not much use to as a synthesizer player, but it's interesting to see what gets output. So we should be able to control the tremolo now through this. At the moment, it's just passing through. So I think the next thing we'll do is have some frequency modulation. So this is the great in Dave. Welcome to the stream. Good to see you. You caught the first synth stream. Yeah, we've been busy with the synthesizer. It is looking quite good now, and we're going to start building some more and more advanced effects, audio effects on there. So I'm going to attempt now to add a low frequency oscillator for frequency modulation, and I made a note of some of the. I don't know if you can see this on camera. On my notes here, I've got the mathematics behind it. I'm hoping I got the maths right. In order to do this, though, we're going to have to actually create our own signal generator class, and I'm going to take the simplest way of doing this. I'm going to go into the NAudio code and just copy the entire class and create my own version of it. Rather than trying to extend it and things like that, I think it's going to be simpler for us to have the complete freedom to kind of mess around with this. So under signal generators, let's go and grab the whole shooting match. So here's the public class, and we'll go to the raw file, and let's just grab the whole class. And we don't need the enum. We just need to go down as far as there. Okay, that should be what we need. And we're going to create a new class. And we're going to call it synth signal generator. We're going to pop that into here. And it's going to be synth signal generator. And we need to bring some namespaces in. Synth generator type needs to be brought in. And there's something right down the bottom here. We need to just close the braces off. There we go. So let's just get rid of some of these comments. We don't need those. Let's get rid of these comments as well, just to make the file a bit more usable for us. And the frequency modulation is not going to be something we're going to control from the front end of our application. We're not going to have controls for this frequency modulation. The frequency modulation is really going to come into its own when we start to try to build instruments. So we start to do presets for different types of instruments, and different instruments will have different kind of frequency modulation features of them. So, you know, if you're playing a church organ, for example, it's going to have a certain kind of frequency modulation, which we can then model as a preset for the various waves that make up a single note. So they're going to be like multi-note instruments. So we're going to have to kind of do a bit of clever stuff with mixers, pre-mixers that mix more than one waveform together to form the final result, which we'll play as a single note. And we'll take a step towards that either tomorrow or on Monday, when we can look at sub-oscillators, just putting in when you play the note A, say in the third octave, also put in an element of the an octave lower, so it gives it a bit more kind of oomph and a bit more of a kind of resonance to the sound. Okay, so what are we going to need? We're going to need a low frequency oscillator amplitude and a low frequency oscillator frequency. Okay, so we can pass those in during creation, I think. So let's create some more properties. I don't like the position of these constructors, so I'm going to move those down below the methods, the properties. Okay, so let's have some more properties. We'll have LFO frequency as a double, and we'll have a double of Lfo Gain. That's going to be the amplitude of the frequency modulation, which will usually be very small. We only want kind of a minimal touch on these things. Okay, so we want to be able to pass into this a double for the LFO frequency, that will be 0.0 normally, and we want another double for the LFO gain. I will default that to 0.0 as well, so that normally when we create this class we won't have any low frequency modulation going on. So that LFO frequency is going to equal LFO frequency, and LFO gain is going to equal LFO gain. So those are the basic parameters. Okay, so now that we come into the mathematics. So I'm going to create a function. So we need to know, we need to be able to sample this low frequency oscillator at every nth sample. So you can see in the sine generator here we have a basic frequency, which is 2 pi frequency, 2 pi f, which is the angular velocity, and we divide that by the sample rate, but we multiply in the brackets here by the nth sample. So which sample is it? It's the first sample, second sample, third sample. And it turns out that n sample divided by waveform sample rate is simply the time. That's your time element. Because it's you know, if you're in the first sample, it's sample 0 over wave format, that's multiplied by 0. If you're on the first one, it's kind of the first element of the first part of the quantized time, or the non-continuous time that we're sampling at. And remember, the sampling rate is 44,100 samples per second. So These are quite small numbers in the end. So what we want to be able to do is within these brackets, we need to. That's basically the frequency, isn't it? That's going to turn it into, when multiplied by the gain, that's going to be the amplitude of our wave. But what we want is our wave to we want the frequency of the wave to vary very, very slightly to give that that vibrato sound. So if you're playing the guitar or the violin and you rub your finger on the fretboard as you're playing your note, and you get that wobble of the note, that's not a volume change as such. So it's not tremolo. What we're getting is rubato, which is a very, very slight change in the frequency of the note, which gives that quite pleasant wobble. And the same if you've got a whammy bar on your electric guitar and you're kind of changing the length of your string at that point, just very, very slightly altering the string to give that frequency modulation. That's what we're going to try and do. So let's just create it up here. I won't leave this method up here. We'll have a private method here. Private, this is going to be a float. Lfo sample, and we're going to pass in there an integer which we'll call n for the nth sample. So this is genuinely winging this, so I've got my maths in front of me. So let's work out what this is going to be. So this is going to return a value, a float value, and so let's kind of wing it and let's see what happens. So so the way this has been kind of done down here is they've created this thing called a multiple, which is 2 pi times the frequency divided by the sample rate. So we can do the same kind of thing really. We can say we can have a multiple, which is 2 pi times the low frequency, the LFO frequency, divided by the wave format sample rate. So far so good. And then the sample value is going to be equal to the gain, so the Lfo gain, multiplied by the sine. So we've got math.sine. So our low frequency oscillator is always going to be a sine wave, so we're going to wobble the frequency by that kind of constant, that continuous kind of sine wave. We're not going to have different types of waves. Okay, so we're going to want to have 2 pi times so no, we've already got 2 pi, so this is the multiple. Going to be n times the multiple. Is that right? Looks okay. So we've got 2 pi times the frequency times n divided by the sample rate, and n over the sample rate is basically time, so it's 2 pi frequency time, which is same as the angular velocity times the time, which is omega t. So yeah, pi omega t. Sorry, a sine omega t. That sounds correct. I think that's going to give us our variance we want. So good afternoon, Ancient Coder. Welcome. We're working on some mathematics at the moment, so we're going to return that. So what we're trying to do, Ancient Coder, is to create a low frequency oscillator to do some low frequency frequency modulation on our notes. We've got tremolo. We did tremolo last night, which is the volume variation by a low frequency oscillator. Now we're looking at changing the this is a double at the moment, isn't it? So let's what's this? That's a double. What do we do to it down here? We just simply change it to a float, don't we? So we'll do the same. We'll just leave it as a double. Yeah. Okay. So let's work only on the sine wave just to begin with. So I would contend, in order to vary the frequency, to modulate that frequency, we simply need to add in the variance created by a low frequency oscillator. So this should be able to multiply we should be add into this rather the low frequency sample at the point end sample. So I think that should give us what we want. So we want to use that formula. I mean, we've got a fairly powerful computer, so we should be able to be capable of doing the mathematics on this on the fly. But we'll want to apply the same process to all these other different frequencies down here, with the sawtooth and the triangle wave and the square wave. But let's stick with just doing on here. Okay. So we've got our sine wave change. We'll experiment with sine waves. Our synth wave provider now needs to take in a synth signal generator. Let me create it here. Okay. So in our main model, what do we do on key down? On key down, we pass in a new synth wave provider. So it's going to generate. So we're going to need to put some work into this part of it. But for the moment, what we're going to do is hard code it. Link Slumps, welcome to the stream. Good to see you. Good afternoon to you. So we're working on frequency modulation by low frequency oscillator at the moment. We've done a bit of GUI work, smartened the GUI up a bit, and just to have a break from GUI because it's not my strength. We're going to see if we can get some frequency modulation going. So in our synth wave provider, let's just feed in some values. So we've got sample rate channels. We'll have 5 Hertz low frequency oscillator, and we'll have a very small. We'll start off with a very small. That might be quite large. The gain of 0.1, and see what we get when we play this. So it could completely break at this point, because my maths may be completely wrong here. Okay, so let's see if we can detect any changes. So let's go to the mid octave, and I'm going to play the note A. So I think that wave is wobbling, isn't it? Ever so slightly. So let's increase the effect. Let's have 0.2 in there. Let's see if we can detect a definite shift in frequencies. Let's play A again. Let's go to the mid range. That's definitely wobbling. Let's increase the effect even more. So let's put this up to 0.5. Let's see what that does. It's quite subtle, but I think it's there. I'll choose the mid octave again. It could be because of the attack, yes, the link stumps. We'll have to fiddle with some of these things, I think. That's definitely wobbling. Let's I think we should be okay with those figures. So let's turn off, so you can see that moving. That's just a note A. We've definitely got a wobble in there. Let's turn off the gain. So let's just remove those figures. Start up again. And we'll stick with the mid octave and play A again. See, that's stable, isn't it? It's not frequency shifting at all. Yeah, so I think we've got an amount of frequency modulation going on there. Let's reinstate those values. Let's make it faster. So let's go for 10 Hertz modulation. See, I'm not sure we need to control these from the GUI. I think these are going to be, let's say, features of instruments. So we definitely got a wobble, haven't we? We can see that this wave is stretching and contracting. Yeah, so that's very good because you can see that the frequency in this area is higher than the frequency at the ends. Let's put a low pass filter into that. Let's cut off right the way down. Not really creating that many artifacts, high frequency artifacts. So the low pass filter is having no real effect there. But on a sawtooth, having no change. But our low pass filter does have an effect on the sawtooth. Buzzy, less buzzy, and we can. Okay, so let's see if we can include the frequency modulation in the other wave types. So we've got our new synth signal generator here. So we've got our formula. This LFO sample formula should just be a matter of being able to drop this portion of the into all of these values. So on the square wave, we should just be able to drop it into here. And the same with our triangle wave. Well, I don't know what effect it's going to have, to be perfectly frank with you, but let's just drop it in each of those places. And white noise and pink noise, they're just random sounds. And the sweep, which is like a rising tone, we don't want to frequency modulate that. Let's have a go and see if we can get some modulation of other waveforms. So we'll go for the mid octave again, we'll go for a sawtooth and we'll play A again. You can definitely see that is being modulated. Those two are the same, aren't they? I wonder if we've got something not set up properly there. Let's have a quick glance at our code, because they sounded the same. So back in our XAML file for the waveforms, triangle, square, sawtooth, triangle, square, sawtooth, and sine. That looks okay. Our main window here, triangle, square, So those look okay. So we are obviously they're just the waveforms look very similar. You'd have thought it maybe it's clipping the top off. Maybe that's why they look similar. So let's have another look at that. So on a square wave, very, very strange because there's a big wobble of sound in there, which is far too big. Let's try it on a sine wave. Yeah. Needs to be kind of a lot more subtle than that, I think. I wonder what the ideal values are going to turn out to be. Because I think 0.5 gain on the low frequency oscillator is huge. So we were doing all of that in the synthwave provider, weren't we? So obviously we're going to need to be able to pass these values in. So let's have those as configurable values. We've got attack, sustain, these base frequency, there's our frequency. So we're going to need to have public, double, Lfo frequency. Get set. Public Lfo Gain. Public double. Get set on that as well. Get set. Okay. Linksumps, from what I've seen of equalizers, they don't normally have some values. They just keep. They don't they normally have some values they keep them at? Yes. Yeah. So you're talking about creating a graphic equalizer there. Were you going to look at doing that as a PR Linksumps? I don't know if that's what you're referring to. But what we're going to do with this frequency modulation, as I say before, we're not going to make it variable as such by the GUI. It's going to be dependent upon the instrument. So the end goal is to be able to start creating instruments or voices, preset voices for our synth. So we can say we can click a radio button and bring up the presets for a church organ or a piano or glockenspiel or whatever we can kind of think of, and they will have those low frequency oscillations in their kind of in the definition of what that instrument is, by dint of the construction of the instrument. So when we try to synthesize it, we need to put those in, and that's why we've got in the signal generators we've got the ability to create white noise and pink noise, because if it's a blown instrument, there will be that kind of small element of hiss or white or pink noise coming from the breath of the person blowing, and we can kind of mix a bit of that into the note, which is a relatively interesting thing to try and do. So so here we can say that the Lfo gain is equal to the Lfo gain and the Lfo frequency to the Lfo frequency. The Lfo frequency, and here we can set our. We're passing those values in there, aren't we? So we can now pass those in from the view model. And we said that 5 is a reasonable 5 Hertz, and then a gain of 0.2. Seems a lot to me for the gain, but it may be that we're simply not detecting it. It's what you've seen in bars, right? Well, if you have any kind of thoughts on all that kind of creating the equalizers links, just start a conversation in Discord. If you're interested in joining us in Discord, here's my Discord invite. So come and join us in Discord and talk synthesizers and talk digital audio for a bit while we're doing this project. You're in there, okay? Good, thanks. Okay. Okay, so I've noticed that we're on 199 followers. So our goal, we're 99.5% of the way to our goal. One more person, and we get our 200th follower. And so if anyone's in chat who is not a follower, do me a favour and press that follow button and get me to 200 followers. It'd be really nice if you did that. Okay, so we've got those values. Let's make sure that still works. So we'll choose the middle octave and we're going to play A. So we're not getting any frequency modulation there at all, are we? Let's see why that is. It'll be in our synth generator here. So we no need to pass them in on there anymore. No, we no need to pass them in there because is that right? What we're doing? Synthwave provider. Yeah, that's correct. So we don't need to pass them in like that anymore. Let's give that another go. If we're getting those values picked up. Oh, you are all in. Yes, I remember now. I'm sorry, I get confused sometimes about who's who. So now we got our wobble. Oh no, it's not. We haven't got any wobble. Okay, so we've lost our low frequency oscillator for some reason. So let's go and figure out why that is. We're passing into our synthwave provider is passing into a signal generator, the Lfo gain and the Lfo frequency. Our signal generator is picking those up here. Let's stick a breakpoint in. So it's coming through as 0, so we're not altering it. Okay. So why aren't we altering it? We're passing LFO frequency of 0.5 in to our synthwave provider. Okay, to our synthwave provider. We're not passing it on, are we, in the synthwave provider? Oh, we are passing it on. But it's probably 0 at that point, isn't it? Let's pop a breakpoint in here. Let's again see what we get, what's going on. So here our frequency This is 0. Okay, we haven't calculated them yet. Okay, so why is that when we've passed them in? Because they're still under construction, is it? What's the best way to do this then? Probably to pass them in on the it's going to be pass them in here, isn't it? And not do that. So the synth signal generator will go back to the form we had before, where we were able to pass in. So it was a double Lfo frequency and a double Lfo gain. And we'll set those up in here. Frequency is the Lfo frequency. Oops. And the Lfo gain. The gain. Okay. And then in our model here, we're going to be passing in synthwave provide, synthwave type, passing in those values. Let's see what happens now. Oops. Oh, I need to give it some defaults. Equal 5. So it equals 0. And it's going to equal 0.0 as well, just as default, so no low frequency oscillator. And we'll put in some, so we don't have to calculate the samples for when it's 0 as well, I think. Let's just get the variation going again, make sure we can actually hear this. So it's still passing as a 0 in. How strange. Let's stop that, start again. I think it's just been a tiring day and I've missed something that I should have done, so oops. So that's coming in as 0. Why is it coming as 0? In synthwave provider, it must be being passed in as 0 at this stage, mustn't it? So in the main view model, these values aren't going in. Default is 0, yeah. Lowercase to capital F, I think. Where's that link? Some sort of line we're talking about there. These values haven't been set, it's saying basic, isn't it? When we're here, when we instantiate this, it hasn't set those values yet. Lfo frequency. Those values have been passed in as 0. New synth signal generator. Lfo frequency, these values are 0. That's a bit disappointing. What's the best way to get around that? What is the best way to get around that? We just need to pass those. When we're setting these, we've already these have been set after we've constructed. Is the problem, I think. And the frequencies are calculated dynamically. Yeah, source dot frequency equals frequency. So let's do something along the same lines as that then. See if we can get it to work like that. So it's our source. So rather than passing those in, as we were before, get back to that, and we'll say that the source dot LFO frequency is going to equal value, and here the source dot Lfo gain can equal the value. Source is going to be our synth here, and we're going to see if we get those passed in. So let's put a breakpoint there. Play. Okay. Yeah, so it's passing in there, so it's 5 now. Okay, let's run it up and see what it sounds like. Go for the middle octave again. A very slight wobble. Interesting, those sound exactly the same. That's really a bit odd. Why do they sound so similar? Maybe they just do. different calculation, isn't it? The square, very similar, except we're taking for the triangle we're taking these values here. Well, I'm willing to accept that that's correct. So we've got a low frequency oscillator doing our variations. So once again, there's the maths behind it all. So you obviously can't see it, but let's just pop into chat and you see if you can see. There's the maths behind it all. So that's how I kind of worked it out from first principles. It's a bit like that really with working with these with the digital audio. You have to resort to mathematics in the end, or you have to search on the internet. No calculus at the moment, but I'm reading a book. I haven't got it with me at the moment. It's called the Audio Programming Handbook, and it's full of complex numbers and Euler's formula and all this. So it's real and imaginary parts of a number. So it's all fun stuff. Yeah, maths. So Dave, welcome. Good to see you. I hope this math goes into the latex comments. Yeah, we'll put. Oh, that's a good idea. We can actually put that in there, can't we? So we can, in here, we can put some CodeRush comments. So let's have a formula. So this is going to be so I wonder how we actually do that. How we do a sign. We got to go and have a look on the website. Maths, yeah, it's maths in the UK, not math. Math sounds weird to me. It's maths or mathematics. Yeah, so I'm a British person, so it's maths. So CodeRush latex formulae. It's formulae for me. It's not formulas. So let's see what it says in here. Looks like we haven't got particular values for sine, so it should be okay. Just to say, it's the sine of two and we got pi. That's just going to put so it was Greek letter pi, so I should have Greek letter pi here somewhere. Slash pi. Two pi. There we go. 2 pi, and then it's 2 pi slash c dot, and it'll be f sub LFO slash c dot n. So let's put some. So that sub hasn't quite worked, has it? So that's got to be sub. Maybe it's in curly braces. Yeah, sub LFO. It's not quite small enough, really. We'll call it just sub L, I think, rather than LFO. F sub L. Want some more brackets around here. Like that. Divided by S sub R, sample rate. And then it'll be A sub L slash C dot So the amplitude of the low frequency oscillator times the sine of 2 pi times the frequency times n divided by the sample rate. I think that's okay. So this is wrong. S sub r is not right. That's going to be sample rate. SR. And then we can say that S sub n, sample at n, is going to be that. That looks okay to me. There you go then. There's there's your there's your formula. Yes, Mr. M is presenting, isn't he? So and we've missed his streams really. Okay, so there we go. It'd be nice if it was not a slash like that. So let's see what they do here. Well, I'd like it to be a horizontal line. He's got the quadratic here. So they have got a horizontal line there, and that's what I'd like. So how are they doing that? So he's got slash frac. Slash frac. Okay, we could try that. Slash frac. What does that do for us? I think. Let's go back and have a look. Problem is, it's because it's 2a. Oh, it's got frac numerator and so it's frac curly braces numerator denominator. So that's easy enough, isn't it? Slash frac. And then we've got the numerator, which is that, and then the denominator, which is that. That look any better? Yes, that's a lot better, isn't it? A bit more compact as well. Let's save that. There we go. Nice. You didn't expect you had to do it. Oh, well, I accept the challenge. I do like these features of CodeRush. So I'm quite happy to do it. Yeah. Thank you very much. Okay, so I think we're pretty much where I wanted to get to. So let's have a look at our GitHub repository and have a look where we got. So low frequency oscillator for modulation. So we've pretty much done that. Add a waveform selector. We've virtually done all that. We've ditched that and closed that. LFO frequency modulation feature added to new class, and it's going to be called synth signal generator. There we go, we can close that. Oh, it's misspelt modulation. Let's just fix that spelling mistake. Take comment. There we go. And we got Lfo. We don't want that Lfo. We wanted low frequency oscillator. Okay, so that's another one down. Another one bites the dust. We've got 7 left. So we've got some work to do on a Tremolo to make that configurable from the GUI, but that's actually written. Sub oscillators is something for another day. Phase shifter and echo effects with serious maths involved. Thank you much, upgrading Dave. Yeah, we've got a nice formula in there. We'll continue to do those. I think they kind of, these features of CodeRush really kind of help to document your code, especially when you can start putting diagrams in. When we start looking at maybe delay and phase shift, we might need to put some diagrams in to show how they actually work and what the inputs and outputs are from that, because it involves feedback loops and wet and dry signals, all these kind of terminologies from audio programming, which you'll become familiar with if you kind of dip into it. And I'll introduce you to some of the some of the features of that. So waveform, we've got the white and pink noise. Whether we need to be able to generate white and pink noise from the front end is another matter, but we'll leave it open for now. In fact, let's just do that, shall we? Let's just actually implement white and pink noise from the front end. It's not as if it's going to be very hard to do. So let's go back to our XAML file and our waveform here. We just need to add a couple of more radio buttons, really. Bang and bang. So this is going to be white noise. Call it white. So white noise generator and then a pink noise generator. Pink noise. Okay, so let's have a look. Doesn't quite fit in, does it? What should we do? Let's lose the pink noise for now. Just have white noise. It's not very exciting. Formula and maths. You did a clip. Oh wow! There you go. We can put that up on YouTube as a separate clip of doing math on stream. There you are for you US viewers. We'll call it math for a little while. Okay, so that's that. Let's then go over to our XAML.cs file. We'll add a new variation into there, which will be white. And there'll be white noise. Oops. Come on. White noise. Let's see what that does for us. So all it'll be is, oh, that we haven't got any white noise, have we? Okay, so why haven't we got white noise? So we've set our signal generator type to white. I didn't select it. I didn't select white noise. That's why. You can see I'm getting tired, can't you? So here's white noise, and it's going to be the same sound. We should be able to put a low pass filter on that, and it changes the frequencies involved. This Q value, I'm not sure exactly what effect it's having. So that's our white noise, and we'll put pink noise on there as well. But I won't do that now. So that's the kind of noise we're going to have. Yeah, I didn't select white yet. So the white noise and the pink noise are going to be when we have our instruments. As I say, it's for the rasping portion of the sound of the instrument when someone blows through it, especially in something like, I don't know, the vibration of the reed in a saxophone. It may be that kind of bit of that fricative noise is going to be what makes it sound more like a sax than anything else, but I'm not sure. Whether we are actually ever going to be able to duplicate real instruments is another matter. So you played the sax and Lynx Lumps. It's a fantastic sounding instrument, but it's really hard to get a good sound out of it to begin with, though. My daughter played the violin, and it took her quite a while to get any kind of decent sound out of it. You played until you got grade 9. So in the UK, there isn't a grade 9. So it goes grade 8 is the tops. You couldn't play a good sound out of it now. Now I imagine it can be very difficult to play. When you get a master playing, it's very soulful, but yeah, when you're not good at it, it can be very, very harsh, I should imagine. Okay, so let's have a quick look at what we changed. So we updated our T4 template, which generated our new view model bindings for us. We've got some more UI elements. So just going to look at the UI elements we created today. I tidied up the envelope off stream. So we added the waveform selector, and we added our low pass filter control. What we need to do next is to add in our tremolo control, and then start thinking about what we can do in terms of other effects. such as echo and phase shifting, which is like that kind of another wobbly or swirly sound you get. I think it was originally done by actually rotating the speakers in the cabinets, but obviously we do it electronically. So a relatively complicated algorithm, but not too bad for phase shifting, I believe. We should be able to cope with writing that on stream, whereas for delay I think it's going to be a matter of finding an algorithm, an open source algorithm, and kind of pinching that. There'll probably be one out there for in C#, and that's in C++ or something, which we can kind of hijack and convert to C++ to C#. Yeah, so that's it. I think we'll what else do we do? Yeah, we created a new synthwave provider. So we created a new synth signal generator. Where's that? There it is. And we updated our wave provider. So yeah, I think that's pretty much what we want to do. So let's push all this up to GitHub. So as normal, all the code will be on GitHub very shortly. You're completely free to copy it, mangle it, call it your own, do whatever you want with it. If you want to contribute to the project, feel free to fork the project and to submit PRs. There are several issues out there which you can contribute to. If you have ideas for other effects or how we can improve or extend the synthesizer, then throw those in again. Okay, so let's push this up to GitHub. First we'll commit episode 37, commit all, and then we'll sync up. Okay, and in a few seconds that should all be on GitHub. Our CI build shall kick off. So where are we? Over here. So I've got it connected up to AppVeyor, and we'll get a build going. So let's let's close add waveform selector. Close and comment. Okay. So we've got 6 open issues. I'm sure I can think of a lot more things we can do. The biggie is going to be the instruments. So what we'll do as part of this issue is actually work out how we're going to do that. Yeah, sure, stable 2,200 followers. I just need one of the kind people in chat who isn't following to to actually follow, and the next person, the 200th follow, I'll gift a sub to, so you get access to Alf here, our alien pal, for a month. But we haven't had any take. I think everyone must be actual followers at the moment who's in chat. So our goal remains elusively close. So I was saying that when we come to this this issue, adding instruments, it's really going to be involved creating the framework for instruments. So to be able to preset the ADSR envelope, to be able to have multiple different types of wave sources contributing, adding white noise or pink noise as a source as well, adding in the low frequency oscillator, and then we'll have a mixer. Each note will have its own mixer, so we'll have to put in lots of different wave sources, and that will mean that we've got a framework for then saying create a church organ or create an electronic organ. Thank you very much, Ancient Coder. I think the reason we've managed to kind of get so far with it is that N-Audio is a pretty good package, so it does provide quite a lot of stuff. So what happened there? Oh dear, link slumps. I've got Nightbot right racked up, so I'm afraid you've got a bit timed out for 5 seconds there. So I do apologise for that, but maybe if I make you a VIP, it'll sort that out. It might be possible to get away with it if you're a VIP. I don't know. Well, we'll do that off stream. I'll make you a VIP because you are one of my regulars now. So yes, as I was saying, that this will be a framework for then being able to say add a particular instrument, and that's when it starts to get more difficult, because I've no idea how to reproduce a church organ or actually it sounds a bit like a church organ already, but you know, when you talk about you want it to be a glockenspiel or or whatever kind of instrument, especially a kind of a plucked string instrument. It's going to be a lot more difficult to do. For example, doing a harpsichord, I've just absolutely got no idea. I'm sure it's a lot more complicated than the kind of features we got available to us. I guess these days a lot of them are sampled, aren't they? So they're very, very realistic. But we're back in the kind of 70s era of synthesizers with our little project here. Okay, so that's looking pretty good. We're starting to close some issues down. Say, do chime in, and if you've got any ideas, if you want to take any of these lots of oscillators, and if you want to really tackle something difficult, some of these effects, or the graphic equalizer, then do chime in. Okay, so let's go and find someone to raid. And usually it would be at this time it would be Code Rush, but I know he's not around. So, Nick Larson is broadcasting by the look of it. So let's go and raid Nick. So Nick does some interesting stuff. He's been working a lot recently with data science, but I'm not sure what he's doing at the moment. So let's go and raid him. Stay with us if you want to join that raid. Otherwise, I'm going to probably be broadcasting for a short time again tomorrow, about 1:30. Sorry, not 1:30. 4:30 in the afternoon my time. Okay, so that'll be my next stream in all likelihood. I do plan to have a short stream tomorrow. Okay, so once again, thank you for viewing the early show. It's been brilliant. It'll be in the afternoon, so that'll be 4:30 in the afternoon UK time, early dev. So do join us tomorrow. Otherwise, I'll see you again next Monday on the next scheduled stream. But tomorrow will be an unscheduled one if it goes ahead. I'm pretty sure it will. So take care, everyone, and let's go and raid Nick Larson.